Okay, so today we're going to talk about Notebook 7, which is about single variable visualizations. So visualizations is the modern way of talking about graphics, the kinds of charts and plots that visually tell a story about the data. And we're going to be talking about how to handle that for single numeric variables, like things like height or weight, okay? So go ahead and get Notebook 7 open and pause the video here till you are ready to go with Notebook 7. All right, so the first thing we're going to do is we're going to start off with a quick review, and we're going to make sure you remember how to create tables and add two tables with the dot with column, and how to use what dot where. Also, this is going to be important for your lab and homework. Knowing how to use NP range this week is going to be really helpful. Okay, so let's jump into the notebook. All right, so let's go ahead and run the first couple cells and get this this first cell running. Initialize everything. Okay, so the first thing, and by the way, you can always get help. I'm going to leave that one commented. The hashtag in front actually creates a comment, but if you do want to look at the histogram table help, you can do so. So bar charts, the first thing we're going to do is we're going to use table.read table to get this top movies um, table imported, but then we're only going to show the only show the movies where the studio is Disney. Okay, so these are all the Disney movies in the table, and you can see all the way back to Snow White in 1937 and Pinocchio in 1940 and various ones along the way. Okay, and so what are we doing here? With columns millions, okay, so this top movies column gross, and then it's divided by what? I can't see quite. So that is divided by 1 million. Okay, why? So we're creating a column that's like the gross column, but it's the gross column divided by a million. So we're going to have a number of millions of gross dollars. Okay. Um, and notice that once we get that created, we're doing with column. The title of the column is going to be millions. And then we're going to take these rounded numbers from this array and put them in. Okay. And for the moment, let me comment this out and let's just display top movies that way. And you can see that it has done that. It's created this extra column here at the end, and we can see that Gone with the Wind, its gross in millions was 198 million. Sorry, $198 million. Okay. And we can see the Star Wars, the gross there was 460 or almost 461 million dollars. Okay, so that's interesting how they've adjusted the table. So let's see what this is. Top movies take NPA range 10. Okay. Well, what does NPA range 10 do? Well, remember, it'll start at 0 and it counts by 1. So it's going to go 0, 1, 2, 3, 4, all the way up to 9. Remember, it stops one item before the stopping criteria. So what's it going to do? It's going to take the first 10 rows of this table and display them. Okay. And it won't have these 190 rows omitted here at the bottom, right? So, oh, I'm sorry. That's what this part did. And so here, what are we doing? We're just showing 10 at the top and doing a bar graph. So we can see the bar graph shows how many millions of dollars that movie grossed. Okay. Now we're doing the same exact thing, except before the bar H, we're doing a sort in millions descending equals true. Why? Well, this is going to show us the top 10 grossing movies. Okay. And By the way, this only goes up through 2017, so that's why we aren't seeing some high-grossing movies from the last 5 years. Um, but Titanic is in there, and Star Wars, and E.T. and Jaws, some of these classics. Look at Gone with the Wind is actually what, seventh on the list, but you've got to remember that the millions of dollars it generated was in the 1930s, right? So, um, and and so due to inflation, that's a huge number for Gone with the Wind. And you actually can look at it, they have this gross adjusted, right? So um, that is something we could actually, um, sort based on, and we could see how Gone with the Wind compares in inflation adjusted dollars to some of these top movies. And by the way, it turns out it fares rather well. It was an extremely popular movie, um, and they sold a lot of tickets. Again, back then the tickets weren't as many dollars, so the gross dollars amount isn't quite as high as some of the other movies, but the adjusted gross is. Okay, so this is interesting. Titanic being the highest grossing movie in this list, well above Star Wars. Okay, and I'm going to move on. There was the sad news about the Titanic tourism submarine, but I'll just move on. So studios equals top movie dot select. So we're just going to have all of the rows, okay? Excuse me, we're going to do just the column of studio, and we're going to have all the different studios here. But notice that they're listed several times, so they're just showing us, hey, group does the same thing, but group is nice. Sorry, group is nice. Why is it not running? Oh, I see. And then I have to run the cell below it to actually see. There we go. And so what studio distribution is the grouping of the studios. And we see that Buena Vista had 35 movies, Columbia had 9, Disney had 11, and Fox had 24. So we've got this grouping. And um, so here with the studio distribution, and notice that we're just adding up the number of movies. We're just going to add up this column right here. Okay, and we're going to see what that turns out to be. And I'll run it. And so there are 200 total movies listed here. And now we're going to do a bar H, right? So the bar H is a horizontal bar graph or a bar chart, sometimes called that in these notes. And let me get rid of the ink and scroll up here, and so you can see the distribution. But it's kind of ugly, so we're going to sort based on count with descending equals true before we do the bar H. Now notice the bar H, we say studio, so the bar H, the column that we list, is going to be the column of names, right? The category variable that we want to create a bar chart for. Okay, so and this one will be sorted descending before we take a look. So getting rid of the ink there, and you can see, now this is actually called a Pareto chart. So this horizontal box plot where we've sorted with descending equals true, right? It makes a really nice bar chart, horizontal bar chart here, where we can see the top um, producing studios here, right? So Buena Vista and Warner Brothers, Paramount, Fox, Universal, Disney, Columbia, MGM. So we can see how many movies each of these studios have in this top movies list. Okay, top movies through 2017. Okay. Okay, so I just want to point this out that we use this a lot. Okay, where we do a dot group and then we sort based on the count or some statistic, right? It might be the average we want to sort, and so we can see um, the highest grossing movies or the highest grossing average group of movies. And then when we do the bar H, this is called Pareto, um, a Pareto chart. I'm sorry, that's Pareto when we do this. And we've done a couple examples like this, and there will be more down the road in this course. Okay, just pointing that out, that's a good one to remember, that we use dot group and then we sort the grouping table. And then we're going to use the bar H, all right? So with these numeric variables, one of the classic visualizations, one of the classic graphics we do is a histogram. And what Python has is this incredibly useful group equals, and it allows us, it'll overlay the histograms for multiple groups. So let's say, if we have a couple of groups like, I don't know, freshman, sophomore, junior, senior, right? We can actually do group equals and the class, the class in school variable. If we name that one, then it'll actually create a histogram for each of those four classes, freshman, sophomore, junior, senior, and it will overlay them on top of each other. So we're going to see this. Also, when it comes to using histograms, the bins is a problem. All right, so the bins are the categories along the x-axis that for which we create the vertical bars in the histogram, and they have to be equal, and there are some rules, but it turns out that not all bins are created equal. Sometimes we have to alter the bins to get a better look at a better picture of the underlying data. Okay, so do I love dealing with bins? No, it's not my favorite thing, but it's often very necessary. This is a very real world statistics thing that we do, working with those bins to get them right. So let's check this out. Okay, so we're going to get the baby table in here, and it's called baby. We're going to call that table baby. And so we have birth weight, gestational days, maternal age, maternal height, maternal pregnancy weight, and maternal smoker. Now, just getting started, this is an old data set, so hopefully these numbers of trues, the number of smokers in this data set, hopefully that would be a lot less now. But this is back when the research was being done about whether or not moms should smoke during the pregnancy. Okay, and look, when you do this, so first of all, I'm going to delete this. Don't delete it, just watch. We'll put it back in just a second. So this is the histogram of birth weights, and you can see this histogram is nicely bell-shaped. That's an important distribution shape. And it looks like it's centered around a little bit above 120, maybe 122, somewhere in there. And it's very symmetric. Okay, very good looking bell shape to our data. And then what does it do when I add the group equals maternal smoker? Well, what it's going to do is it's going to take this column, it's going to group based on this column and produce two histograms, right? One for the smokers and one for the non-smoky smokers, all right? So, sorry, I'm going to scroll this back up so we can see it. And then when you run it, you can see that the smokers are in gold and the non-smokers are in dark blue. And the dark blue is behind, so you can see its shadow kind of through the gold. So what are we seeing here? Okay, this is a really nice picture, right? That look at what's on the x-axis. We have birth weights along the x-axis, so how heavy the baby was. I believe this is ounces. And how heavy the baby was when born. And again, back when this data was collected, they were using birth weight as a stand-in for the health of the child. Now, in modern medicine, we know that a baby can weigh too little and can weigh too much. There can be problems on either end, but basically they're just saying, hey, the heavier babies were the more healthy babies, the lighter babies were less healthy. And if we're using it that way, you can see that the blue bars appear to be shifted a little bit to the right. And the yellow bars appear to be shifted a little bit to the left. So what are we seeing here? We're seeing a birth weight that favors the non-smoking moms. Their babies, according to this measure, are more healthy on average, okay? That's what it's a really nice graph to show that. Okay, so baby group on maternal smoker, and you can see what I was saying, that we have a huge number of smokers in this table, which is good for comparison purposes. But again, I would hope that that's a much higher number of smokers than we would have in a current data set if we were to collect data like this today. Okay, now what's going on? So we're going to group based on maternal smokers, and we're going to do a bar H, and then this is all the kind of stuff that we will give to you. Don't worry about this. This is the part that you guys do, the dot group and the bar H, okay? And so these others, these titles and labels, right? And then the ticks, that helps, that assists with the spreading them out so they don't end up over laying on top of each other. So this is just prettying up our bar chart with some nice labels for the X and Y axes for the overall chart. And you can see that there were a lot more non-smokers than there were smokers, although still a distressingly high number of smokers, okay? And we're going and we're getting these top movies column year, and we're subtracting from 223. Why? Because we're creating this array called age. And then we're using with column to add the column age on the end of top movies. And there we go. Sorry. I'm going to pause this and check out what's happening. Okay, so what had happened was I had not run this cell. So when I run this cell, which actually does add the column age using the array that we created in the line right above it, then when I run the top movies cell, then I get what I was expecting, which is this age column to be added on the end, and it tells me the number of years old, the number of years prior to 2023 that this was created. The film was released actually. Um, okay, and so now we're going to talk about binning. Okay, so the min of the ages and the max of the ages, we have movies that are between 6 and 102 years old. Okay, so now look at this array that we're creating, and we're calling it my bins. Okay, well, I'll show you why in just a second that we're doing that. And so here is we're showing the bins, so you can see, from 0 to 10, you can see how old the movies are, or how many movies there are that are that age old, okay? So it appears the most we have are the movies that are between 20 and 30 years old, okay? And so when we sum the ages, right, the age count, we have 200 movies, just like we should. And you can see now we're summing up the bins, and we're creating this with MPA range. All right, count by 25, so that's how we're getting the bin column. Okay, and so we've got all these different bins, okay? And just a reminder of how to use the dot where. So let's look at these histograms. Okay, so we've got my bins, and we've got the bin data, all right? And let's look at the histogram. So here we are not using any bins, right? It's just dot hist and the column we want it. And notice that, you know, the histogram looks okay, but it's definitely not bell-shaped. And so there might have been some sorting that we did that made it that way. Okay. And now look, we're going to do this bins equals. All right. So I want you to pay attention to this when we do the bins equals, and we're putting in the NPA range. So the bins are going to be 10 units wide. We're going to start at 0 and we're going to go up to 100, counting by tens. Okay. And let's get rid of the ink and run it. Interesting. Okay, so now it turns out that some of these bins here just weren't working as well. So the computer generated bins, if you'll notice, when we scroll up, right, they look very different than the same bins over here. And it looks like these bin widths are more than 10. They're closer to like 15 or something, whatever the computer picked out as bin widths. Okay, so here you can see that we get a better picture when we use these bins. Okay, and that's the whole point of binning, because sometimes there is some story in the data that we can't see with the computer generated bins. Okay, and now here we did density equals false. What happens here? Well, now we're looking at roughly the same thing except for the y-axis in counts. Up here, the y-axis is in percentage. So the percentage is out of 200 movies. So, you know, 25% is 50 movies. So we have kind of the same thing, right? So you can see that the graphs look similar, but the main difference there is the, oh, that's percent per year. Okay, that makes sense. Okay. And this is back when we do the ages without specifying any bins. Like, let's try not specifying any bins. So this is why we're doing it, okay? And I'm going to leave it there. The binning question is tough. Sorry, I'm just going to run through these so that this step works. And what are we doing here? So we're finding where the bin is equal to 40 and getting the column percent and then the first item out of there. Why? Well, because it was equal to 13. Okay, and then to calculate the width of the 42 to 66 bin, we're just going to run this, right? And then we're doing percent per width, right, is what we're calculating to get the height of the bar. Okay, and so the first bar there is the 0.54. All right, so it's just showing you how to get those percent per width. When the histogram shows you percent per width, that's how it's doing the calculations. All right then. What are the heights of the rest of the bins? And again, we're just doing the same calculations, and now we have this column called height, and it's letting us figure out, you know, the height of each of the bins. Okay, so here's the bins and the graph. Okay. And one final time, we're going to show the impact of the bins. So here is the survey data, and we have sleep bins. And if I use the sleep bins, oh, that's ugly. However, if I change the sleep bins Okay, so there's the impact of bins, right? Here is a graphic which kind of shows what we'd like to see, but it's a very ugly graph. And when we use fewer bars, fewer categories, and get this much neater, we get a very bell-shaped figure. Okay, so enough about binning. Again, that is important, being able to change the bins on a histogram, but let's move on to a very important graph called a box plot. Okay, so a box plot is a picture of the 5-number summary, and here is what the 5-number summary is, right? We have the minimum, we have the 25th percentile, which we call Q1, we have the 50th percentile, which, you think about it, is the median, or it's very close to the median, and Q3 is the 75th percentile, and then the maximum. Those are the 5 numbers, and the box plot is going to have a line at each of those numbers, and then it's going to display a rectangle around the middle half of the data, right? So it's going to have a rectangle that covers these values. So we'll be able to see the middle half of the data. We'll also be able to see any outliers, okay? And sadly, no group option exists for box plots. So to show 2 box plots side by side is a little bit exciting. And let's jump in. Let me get rid of the ink and let's jump into the notebook to see. Okay, so we've got the skyscrapers data, and notice that we've created an NY table, which is where the city is New York City, and we have an LA skyscrapers where the city is Los Angeles. So this table we're shown is just NY. Okay, now look, we're doing a box plot. So notice how we start. We start with plots, box plot, and then NY column 3. Okay, so we got to look at this. Remember, the computer starts counting at 0. So name is 0, and material is 1, and city is 2. And there we go. Height is 3. All right, so I'm going to get rid of the ink. But when we call a column by its number, we are allowed to do that. But you have to remember that the computer will start counting at 0. Okay, and width equals 4, that's just controlling the size of the figure, and you can see exactly what I said. Okay, so we have the minimum, we have the 25th percentile, the 75th percentile, the median is shown in a different color, the maximum, well, I've marked this. It's the maximum if there weren't outliers, and then the box plot actually shows anything above the upper fence as an outlier. Okay, so that's our first box plot. Let's see what we have down below. Okay, and we've added a couple of labels, right? So we've got a label of NYC, which is showing, just showing this down here, right? We have a title up here. This is actually a hard return in the text there. So this stuff is just prettying it up, okay? So the basic code is not that hard. And we have this option I want to show you now beyond just the width. So when we do a box plot and we add a show means equals true, it's going to create something in here, right, to let us see what the mean is, because the colored line, that orange line or red line, whatever it is, whatever color you think it is, or whatever color it shows up on your computers, is the median. Oh, but here we go. There is a yellow triangle now, and that's because of the show means equals true. So the orangish reddish line there is the median, and the triangle, the yellow triangle, is the mean. Okay. And this is a wider one. Width was changed. It's basically the same exact box plot. Okay. So if I want to compare two, look at this. We're going to have box plot with New York, a box plot with LA. This, don't worry about this. We could just change the title by just changing the stuff that's in red there. Labels is just going to be what's below each box plot. Leave this alone, okay? And let's see what it does. Okay, so it puts them side by side and gives us a title. And again, these are the labels. Okay, and what do we see? Well, we see a lot more outliers in New York. Okay, so there's just a handful of really tall skyscrapers that are between what 300 and 550 meters tall, which is tall, close to 1,000 feet or more. And that's a tall building. Okay, LA. Now, why the difference? You notice that the medians aren't all that different. Maybe slightly different. We can't tell. Why aren't there a bunch of really tall buildings in LA? Well, one reason might be that they have earthquakes on the West Coast. And the taller the building, the harder it is to make it. So you can actually you can't make a building earthquake proof, but you can make a building that's less likely to crumble when when there's an earthquake. But that's harder to do with these really tall buildings. A really tall building is going to um, it's going to be catastrophic in an earthquake. So perhaps the earthquake issue is what we're looking at here. But you can definitely see a nice visualization of the two different cities. Okay, and what's going on here? We're just adding a couple more options. Okay, and we still have labels and we still have titles and they're just a little bit wider. Okay, and here is the birth weights, and we're comparing non-smoking moms to smoking moms. Okay, and what's going on here? I'm just going to say that this is probably one of the best places to get the side-by-side box plots. Um, we're not going to expect you to put this whole thing together. What we'll expect you to do is copy paste and then create the smokers, create the groups, right? So we have smokers group, we use a dot where to get the maternal smokers is true, and then the column that we want is birth weight, right? Same thing where maternal smoker is false, column is birth weight. Then leave this alone, although we can change the labels. All right. And everything else is there for you. And again, you can change the title. So basically, you change the first two rows of this code to be for the data that you're interested in showing the box plots for, and then you just change the stuff in red in the fourth row and last row. And again, you'll get a nice picture, although the smokers and non-smokers, the labels are a little a little jacked. Um, okay. And this is just showing one last feature um, on the histogram. Okay. So um, again, just say this, that you may need this later in the course. And if you do, the side-by-side box plot code is in Notebook 7. So make a note somewhere for yourself so you can remember that. Okay. And the last example is this Galton table, which compares children's heights to parents' heights. And then we're going to show how to get multiple histograms displayed at the same time. Okay, this is a really useful visualization a lot of times. So let's see. So we're just investigating. There's 934 families that are, or kids that are listed here with their parents' heights. And I guess I should glance at this, right? So mid-parent height, it's not exactly the average of mom and dad, but it's close. I don't know exactly what Galton did to create the mid-parent height, and it's in our textbook, so I'm not going to go over that. So we have how many kids the family had, how tall the mom and the dad were, their mid-parent height, how many children there were, the oh, I'm sorry, family number is just an ID number for the family. Okay, how many children they had is here. Which child? This is the first child. It was male, and this is that child's height. There are other children from the same family. Okay. So Here's a histogram of mid-parent height. Okay, well, this makes sense. Remember that 72 inches would be 6 feet tall. So, right, we have a lot of people that are 5'8" to 6 feet, which makes sense. That is typical for a lot of adults. Okay. And then, so that's the mid-parent height. That's, again, that's sort of the combination of the mom and dad's heights. And then we have child height, which is a weird looking graph, not quite bell-shaped. And then how many of them are taller than 5 feet 10? Well, look at this left end equals option, and it draws a line there, a vertical line at 70 inches, and then it highlights. And so the left end being there, it highlights gold to the right. So that's just another way to kind of look at the histogram. Now here, look at this, Galton histogram, mid-parent height, comma, child height. So notice that these are different columns in the table, right? So we list two different column names, and it plots them together, superimposed on top of each other. Now look at this, and I'm sorry, we've got the, I'm going to pause the video because I'm running out of battery. Okay, so what we're doing here is we have specified four different columns: the mother's height, the father's height, the child height, and the mid-parent height. And now it's displaying four histograms superimposed on each other. And let me just say that we don't do this that often. As you can see, it's pretty busy. The graphics are busy, the colors are hard to tell apart. So this isn't perhaps the best use of the histogram. Okay, and then what do we have here? Here we have, now the box plot is actually nice, right? So we can see, and I'm sorry that the, can't quite see the whole thing, but you can see the mid-parent, the child, the mother, and the father, and their relationships of the whole data sets to each other. So that is an option for, what are we doing here? Well, we have a dot column mid-parent height, dot column child height, right? So these are all, so it's basically doing all of them together. And then this ticks is actually controlling them to spread them apart. And then the labels that we have up here. You won't have to do this later in the course. We usually side by side, just two is mostly what we do with box plots. But when you do multiple box plots side by side, it is a really nice visualization. Okay, so that's how we're going to deal with single variable numeric variables and the different kinds of graphics that we're going to use in this class.